So to make this width to be 2, here width is equal to 6 or width is equal to 6, but our required width is equal to 3, our required width is equal to 2. So you have to compress the signal is nothing but we have to scaling you have to do a scaling operation. So by taking 6 by 2 is equal to 3, 6 by 2 is equal to 3, by doing this f of 2t, then width will become original width divided by 2, will get the width is equal to 3. So this is the required width. By getting the required width, we have to do the scaling operation. So I am taking as a minus f of minus 2t, Now this is equal to, this minus 2t nothing but 2t is equal to 1, t equal to 1 by 2. T equal to 1 by 2, so we have to multiply this 1 by 2 with the each and every instance of the signal. So minus 4 into 1 by 2 is minus 2, 2 into 1 by 2 is equal to 1. Now we have to see we have to observe the corresponding time instances. Here time instance equal to minus 1 to 2. Now here is equal to minus 2 to 1. Say the same shape. The shape of here is a triangle. Here is like a sawtooth plus triangle. Here is like a sawtooth plus. Everything is clear, but the limits point of view we have to adjust. So without disturbing the shape of the signal, we can use the delay and the shifting operation. We can use the delay or advance. So here equal to minus 2. Minus 2 should become minus 1. So we have to add minus 2 plus 1 it will become minus 1. So we have to do some delay operation. I am writing here equal to minus f of minus 2 into t minus 1, minus f of minus 2 into t minus 1. The corresponding t minus 1 is equal to 0, t equal to 1 if you add, the corresponding signal will become from minus 1 to, the corresponding signal will become from minus 1 to something, and this one will become 2. This minus 2 plus 1 equal to minus 1. This 1 plus 1 is equal to 2. This 1 plus 1 is equal to 2. Here what are the amplitudes are? Amplitudes are here is equal to 1 and here is equal to minus 2. Here is your 1 and here is equal to minus 2. Here is equal to minus 2. Now what you want, but you want here this should be minus 2 signal. I am going to multiply this signal with minus 2 doing the amplitude scaling. This is equal to minus 2 into minus 2 f of minus 2t plus 2, minus 2 f of minus 2t plus 2. The corresponding signal will become listen. The corresponding signal will become simply the amplitude will be raised to 2 here, and here the corresponding amplitude will become, here the corresponding amplitude will be minus 1 2 only. Here amplitude is equal to 2 and here is equal to minus 4. Here is equal to minus 4. This is the signal. Now by adding some DC signal of value is equal to 2. This will become, that is 2 plus minus 2 into f of minus 2t plus 2, 2 plus f of t into minus 2 plus 2. This will become, here equal to value is equal to 0 because of adding this 2. So this will raise to this up to this level. The corresponding amplitude is equal to 2. Corresponding amplitude is equal to 2 and the corresponding amplitude here is equal to 4. And now the signal will become, here it is equal to value is equal to 2, here value is 2. Now what about this value? Here this value is equal to minus 4. Minus 4 plus 2 corresponding value is equal to minus 1. Corresponding value is equal to minus 1 and here value is equal to 0. By adding this 2, this you will get the corresponding amplitude is equal to 2. Corresponding amplitude is equal to 2. This is your original signal g of t. So g of t can be represented as the 2 minus 2 into f of minus 2t plus 2. This is a way of representing one signal in the form of the other signal. First we have to observe the two signals. With respect to the shape point of view. Here the signals can be, if you observe the signal, this is the sawtooth pulse, and after that this is looking like a triangle. After observe this one, up to this it is a triangle, and after that it is a sawtooth pulse. First of all we have to adjust the signal f of t in the shape of the signal g of t. To the shape of the signal g of t by doing this minus f of t and minus f of minus t. Now after adjusting this one, we have to adjust the width. This is the shape adjustment. After this we have to adjust the width point of view. Here width is equal to 6, here width is equal to 2, width is equal to 3. By doing the scaling operation, the width can be compressed, the width can be reduced and compressed. Signal can be compressed. Signal is equal to this one. After this point of view, we have to observe the instances. What are the time instances? Here equal to minus 1, that is 2. So how can we get this minus 1 and 2? Here the delayed version or the advanced version. Depending on the instances, we have to get a conclusion about the delay or advance. Here equal to minus 2. Here we have minus 1. To get the minus 1, we have to add plus 1 to the signal. Plus 1 to this signal is nothing but, in function point of view, this is the delayed version. Minus 2 into t minus 1. Minus 2 into t minus 1. And after that, by doing some modification with respect to the amplitude, we will get the original signal. Very, very important concept it is. Not only here, in the Fourier transforms, it will play a very important role. Because some function they will give you f of t having the Fourier transform f of omega. What is the Fourier transform of g of omega? In terms of f of omega, they will ask you at that situation, you have to get an idea, you have to know how to represent the signal, one signal in the form of the other signal. Now coming to next one. Coming to next one, the given signal f of t equal to f of t, they have given the limits from -2 to 4, -2 to 4, and they are asking about the g of t. The limits are from, they are asking about the g of t. The limits are from where to where, 0 to -3. Here width is equal to 6 and here width is equal to 3. Okay, that thing we will see later. First we have to adjust the shape of the signal. First we have to adjust the shape of the signal. Now I am writing minus f of t here, minus f of t here. This minus f of t will become this equal to, this is your -2, this is your -2, and the corresponding value this is equal to 4. This is -2, corresponding value is 4, and amplitude will become -2. Amplitude will become -2. Now here width is equal to 6, width is equal to 6. But here the corresponding width is equal to 3 only. Width is equal to 3 only. By doing which operation? We can reduce the width by, we can compress the signal by doing the scaling operation. So simply if you write minus f of 2t, minus f of, simply if you write minus f of 2t, the corresponding signal will become, this will become -2 will become -1, and this 4 will become 2, this 4 will become 2. This is the signal you have, the signal we have. Now directly if you do the now with respect to limits point of view, you have to see here this limit is equal to 2, here the limit is equal to 0. So by doing 2 minus 2, we can make this to be 0, we can make this to be 0. So I am writing here is equal to minus f of 2 into 2 minus 2, minus f of 2 into t plus 2 I am writing, minus f of 2 into t plus 2 I am writing. If I write it like this will become 2 minus 2 is equal to 0, and the corresponding signal we have -3. Corresponding signal -3, this is equal to -2, this is equal to -2, and what you will get here is equal to 0, here is equal to 0. This is the corresponding signal. It is looking like this g of t, looking like this g of t, but not correct, because here the corresponding value is -2 you got, but in g of t the corresponding instant equal to -1, the corresponding instant is equal to -1. So the procedure whatever you got is the wrong here. Then what we have to do? Simply by seeing we can say here this is width is equal to -3 of -1 is equal to 2. Here up to this level only I am considering the width. Here this is equal to 2, so corresponding width here is equal to 2. So this width should be shifted into the left side, should be shifted into the left side, and this should be repeated to the right side, the positive side. So by doing the operation minus f of -2t, so minus f of -2t. So by considering the instance also very important. Minus f of -2t nothing but simply it will become -2. And this will become 1, and this will become your 1, this will become 1. The corresponding signal is equal to like this. Now the corresponding limits what they are asking, this -2 should become -3, this -2 should become -3 by adding what, we can convert this -2 to -3 by adding 1, -2 -1 is equal to -3. That is nothing but t equal to -1 we are adding. That is the function point of view should be t plus 1, right? T equal to -1 we are adding. That is nothing but t plus 1 is equal to 0. So the corresponding is equal to minus f of -2 into t plus 1, minus f of -2 into t plus 1. If you write like this, the corresponding signal will become, how will it become? This -2 -3, the corresponding here is equal to -1, and 1 will become 0, the corresponding signal will become of like this. This is your required signal, g of t. So g of t can be called as the minus f of -2t -2, minus f of -2t -2. Got it? Minus f of -2t -2. Very important point, very important this one. With the amplitude point of view, here if they have given 1 here, then simply you can do 1/2. So 1/2. Amplitude is not a matter. Okay, amplitude is not a matter. If it is 2, then minus f of -2t -2. If the amplitude is equal to 1, simply this will become minus 1/2 f of -2t -2. Very important problems. These two problems try to do 2 times. Not one time, try to do these two problems in 2 times, because with respect to this limits point of the shape looks like this only, but the limits point of instantaneous point of view, this may be different. If this shape can already we have written is equal to minus f of 2t, 2 into t plus 2 already we have written. That also shape is equal to like this only, but the instances were not matching. So because of that we have to concentrate, we have to consider the widths carefully. After that only we can get the correct answer, which is equal to -1/2 -2t -2. The wrong answers are available in the options. Okay, wrong answers are available in the options. If you directly put that answer, that answer will be wrong. So be careful about this one. Now coming to fourth one is the signal is something they have given. They are asking to sketch the signal. 1 plus sigma 1 SGN is nothing but sigma 4 minus t. 1 SGN is nothing but sigma 4 minus t. What is the sigma of signal? What is the sigma of t? Sigma of t equal to simply this is equal to 1 per t greater than 0 and minus 1 per t less than 0, minus 1 per t less than 0. And what they are asking, sigma of minus t plus 4. Sigma of, this is the combination of sigma of minus t plus 4. This is the combination of shifting and the scaling, shifting and the reversal. Our procedure is first is the shifting and then scaling. So I am writing this sigma of t plus 4. Sigma of t plus 4 is nothing but t plus 4 is equal to 0, t plus 4 is equal to 0 and t is equal to minus 4. T plus 4 is equal to 0 and t equal to minus 4 to be added to each and every instance of the signal. Here the signal is equal to 0. By adding this t equal to minus 4, this will become, by adding this t equal to minus 4, this will become here equal to from minus 4 onwards. Greater than minus 4, the value is equal to 1 and less than minus 4, this value is equal to minus 1. Our required is the sigma of minus t plus 4. Sigma of minus t plus 4 is nothing but simply minus t is equal to 1, t equal to minus 1 to be multiplied. All the extent of this one here equal to minus 4 equal to minus 3. So this minus 4 will become 4. This minus 4 will become 4. 3 minus 3 will become 3. Minus 3 will become 3. The corresponding amplitude is 1 here. So less than 4, this amplitude is 1. Greater than 4, this amplitude is minus 1. This is your sigma of minus t plus 4. Sigma of minus t plus 4. Our intention is that 1 plus sigma of 4 minus t. 1 plus sigma of 4 minus t means you should add the DC signal to this one of amplitude is equal to 1. DC signal of this amplitude is equal to 1. Up to 4, this value is equal to 1 and this value is equal to 1. 1 plus 1 will become 2. 1 plus 1 will become 2. After 4, what about this? This value is equal to 1 and this value is minus 1. 1 minus 1 will be 0. 1 minus 1 will be 0. So you can write this signal as like this. For 4 up to 4, this value is equal to 2. This is your signal, required signal. This is your required signal 1 plus SGN of minus t plus 4. 1 plus SGN of minus t plus 4. This is the way of writing or way of adding the signal. Adding the signal is nothing but simply adding the corresponding amplitudes at the corresponding instances. What is the value of amplitude t equal to 0? You have to consider. You have to consider corresponding amplitude to be added to the other signal. Added to the other signal with the required information. Now sketch the signal 3 into, next question, sketch the signal 3 into triangular of 2t by 3 plus 3 into rectangle of t by 3. 3 into rectangle of t by 3. Try to sketch the signal. Simple only. Already you know how to represent the triangle of t. How to represent triangle of t. With the knowledge of that one, simply by doing the scaling operation, we can write the required signal. The required signal is equal to x of t they have given. They are asking what about this x of t at t equal to 3 by 2. T equal to 3 by 2. We can write x of 3 by 2 equal to how much? 3 by 2 equal to how much? Now coming to the first question, this 3 into triangular of 2t by 3. 3 into triangular of 2t by 3. Already you know the triangular a into triangular of t. How can you write a into triangular of t equal to? Simply, I told you here whatever the denominator is there, that will be your width by 2. That will be your width by 2. So this can be represented as 1. Suppose here 1 is there, 1 is equal to width by 2. So corresponding width is equal to 2. So this is from minus 1 to 1. This A is the corresponding area. With this information, I am going to writing this one 3 into triangle of 2t by 3. So that can be represented as the 3 into triangle of t divided by 3 by 2. 3 into triangle of t upon 3 by 2 plus 3 into rectangle of t by 3. How can we represent rectangle of t by 3? Rectangle of t by 2 is equal to, already we have seen, simply this denominator value is your width of the signal. So this is equal to minus tau by 2 to tau by 2. This is your amplitude, this is equal to A. The corresponding is your amplitude. Already we know how to represent. Now coming to this one here the width is equal to 3 by 2. So width by 2 is equal to 3 to, so width by 2 is equal to 3 by 2. Here width divided by 2 is equal to 3 by 2. So corresponding width is equal to 3. Here width is equal to 3 only. Here width is equal to 3. This is rectangle, this is triangle. Here width is equal to 3 only. So to make this width is equal to 3, how can you write? To make this width is equal to 3, okay, how can you write? This can be represented as the minus 3 by 2 to 3 by 2. Minus 3 by 2 to 3 by 2. The corresponding amplitude is equal to 3. Plus we have to add this signal. So width is equal to 3. To make minus 3 by 2 to 3 by 2, corresponding amplitude is equal to 3. These two signals we have to add. Addition is nothing but simply adding the amplitudes at the corresponding time instances. Here t equal to minus 3 by 2, this value is equal to 0. At t equal to minus 3 by 2, this value is equal to 3. This value is equal to 3. So you can write this value is equal to 3 at this place, and after that t equal to 0, this value is equal to 6, this value is equal to 6. So the corresponding representation of the signal is equal to like this, minus 3 by 2 to 3 by 2. This is our required signal f of t. This is our required signal f of t. Now draw sketch of the signal. Simply here the concept is that you have to remember this one. No need to remember. Remember, okay. In examination directly they will give you the notation. The notation is 3 into triangle 2t by 3. The corresponding notation they will give you in the form of the pulse. In the form of the pulse, depending on that only. Here I consider width by 2 equal to this one. In examination they may give you width is equal to directly. So in examination notation they will give you width is equal to notation. Depending on the notation you have to go. If they did not mention any notation, the default notation is equal to this one only. If they did not mention any notation or anything with respect to the triangular or rectangular, we have to consider these method only. This is the method to represent the triangle or rectangle pulse. Now coming to the second question, x of t equal to something they have given 2 into triangular of 2t minus 1 plus 6 into rectangular of t by 4. They are asking what is the value of x of 3 by 2. X of 3 by 2. First of all, I am writing this one is 2 into triangular of 2t I am considering. 2 into triangular of 2t I am considering. So this can be represented as 2 into triangular of t divided by 1 by 2. So width by 2 here is equal to 1 by 2. So width is equal to 1. Width is equal to 1. So the corresponding signal can be represented as minus 1 by 2 to 1 by 2, minus 1 by 2 to 1 by 2. Getting my point. This can be represented t divided by 1 by 2. So w by 2 equal to 1 by 2. Width by 2 is equal to 1 by 2. So corresponding width is equal to 1 only. To make this width is equal to 1, we have to write minus 1 by 2 to 1 by 2. Corresponding amplitude is equal to 2. But we want 2 into triangle of 2 into t minus 1. 2 into t minus 1 is simply direct version. If we have the signal like this 2 into triangle of 2t, simply you can write this is the direct version of the signal only 2 into triangle of 2 into t minus 1. The direct version of this one only t minus 1 is equal to 0, t is equal to 1, you have to add. By adding this t is equal to 1, this will become 1 by 2 to 3 by 2, 1 by 2 to 3 by 2, corresponding amplitude is equal to 2 only, 1 by 2 to 3 by 2, corresponding amplitude is equal to 3 by 2 only, 2 only. Now this plus we have to add some one more signal is there, 6 into rectangle of t by 4. What is the 6 into rectangle of t by 4? Okay, you write here the width is equal to 4 only. Here the width is equal to 4 only. That is nothing but the corresponding signal can be represented as the minus 2 to 2. The corresponding signal minus 2 to 2, the amplitude is equal to 6. Minus 2 to 2, the corresponding amplitude is equal to 6. These two pulses we have to add. After adding these two, what is the value at t equal to 3 by 2? They are asking. What is the value at t equal to 3 by 2? They are asking. Simply the value at t equal to 3 by 2, this one plus the value at t equal to 3 by 2 will give you the final answer. Now, what is the value at t equal to 3 by 2 here? Here the value at t equal to 3 by x of t at t equal to 3 by 2. Here this value is equal to 0 at 3 by 2. So 0 plus what is the value at 3 by 2? Nothing but 1.5. 3 by 2 is nothing but 1.5. From this the corresponding value is equal to 6. So you can write the corresponding value is equal to 0 plus 6 is equal to 6. 0 plus 6 equal to 6. Now, like this here, the only point is the representation of the signal, the triangle signal or rectangle signal in the form of pulses, in the rectangular pulses, in the form of pulses only. After getting, you can write anything, whatever they want. Now listen, this del of t equal to what do we know? Del of t not equal to 0, but del of t not equal to 0. For t equal to 0 and equal to 0 other than the values of 0. So you can represent this del of t equal to only exist at the t equal to 0. This amplitude is going to be infinity and area under this impulse is equal to 1. I am considering some signal, random signal x of t. I am considering some random signal x of t, some signal, anything you can consider this x of t. Upon multiplying these two signal, what will happen? This is the question. Upon multiplying these two signal, what will happen? Del of t equal to how much? The question is this one. After multiplying this signal, because the impulse signal is existed t equal to 0 only, so the instances other than this 0 multiplied with anything is equal to 0. What is the value of this x of t at t equal to 0? The corresponding value is equal to x of 0. So you can write this signal as the x of 0 into, after multiplication of these two signals, x of 0 into x of 0 into del of t. The corresponding signal can be represented as a x of 0 into del of t. So x of t into del of t can be called as x of 0 into del of t. X of 0 into del of t. Now on further extending this one, this is x of t into del of t minus t naught. I am writing del of t minus t naught. Directly you can write del of t minus t naught is nothing but the signal impulse exists only at t equal to t naught. Exists only at t equal to t naught. So this can be represented directly as the x of t naught multiply with del of t minus t naught. Del of t minus t naught. If you take the integration, what will happen? If you take the integration, what will happen? That is integration of x of t. That is integration of x of t del of t dt from minus infinity to infinity. What will happen? This value is equal to direct now we know is equal to minus infinity to infinity x of 0 into del of t dt. X of 0 and del of t dt. The x of 0 is constant. We can take it as out and area under this is equal to 1 only. So this directly we can write this value is equal to x of 0. This value is equal to x of 0. And further we can generalize it. This x of t multiply with to del of t minus t naught is equal to x of t naught into del of t minus t naught. And by taking the integration of this signal minus infinity x of t into del of t minus t naught dt is equal to simply x of t naught, because the integration of this area under this impulse is equal to 1, because of the area under this impulse is equal to 1. Suppose if you consider a question, they are given as integration minus infinity to infinity 2t plus minus infinity to infinity some 2t into del of t plus 2 dt equal to how much? Del of t plus t equal to how much? Here x of t equal to 2t and the impulse is equal to del of t plus 2. It exists only at t equal to minus 2. It exists only at t equal to minus 2. So correspondingly the signal can be represented directly as a 2 into minus 2 is equal to minus 4. 2 into minus 2 is equal to minus 4. If suppose the limits are like this, suppose the limits are like this from minus infinity to limits are from 0 to infinity 2t into del of t plus 2 2t into del of same example. The limits I have taken 0 to infinity is nothing but here the impulse is existed t equal to minus 2, right? T equal to minus 2 and the limits we are considering from 0 to infinity. So this from 0 to infinity, this value direct first of all I wrote this value is equal to 0 to infinity 2 into minus 2 into del of t plus 2 dt. So this is equal to minus 4 into 0 to infinity del of t plus 2 dt. Because of this del of t plus t existed t equal to minus 2, but the limits are from 0 to infinity. So in the 0 to infinity there is no impulse exist. How can I calculate the area? So the corresponding area is equal to 0. So by applying this property, we have to concentrate about the limits. Whatever the question they have given. Okay, simply substitution only. When observe wherever the impulses exist. Other the impulses exist in the given limits or not. If it exists, then directly you can write. If not exist, we cannot suppose it to write this one. Suppose integration minus infinity 2t plus 3 into del of 2t plus 3 equal to how much? Del of 2t plus 3 dt equal to how much? If the limits they have given minus infinity, no doubt at all, the given impulse wherever it should be exist, it should be present in the given limits, because we are considering the throughout the axis from minus infinity to infinity. Now what about this question? So the del of 2t plus 3 can be represented as the integration minus infinity 2t plus 3 multiply with this del of 2t plus 3 can be represented as 1 by 2 into del of t plus 3 by 2. Already we have seen in the previous session del of t plus 3 by 2. So this del of t plus 3 by 2 existed. The impulse t equal to minus 3 by 2. So this can be represented as the 1 by 2 integration minus infinity 2 into minus 3 by 2 plus 3 multiply with del of t plus 3 by 2 dt. This 2 will get cancelled. 3 minus 3 is equal to 0. So this value is equal to 0. Because this expression 2t plus 3 at t equal to minus 3 by 2 equal to 0. In previous question the answer is 0 because the impulse not exist in the given limits. Okay, right. Here this answer is because 0. Don't be confused. It's 0 because of the expression is going to be 0. Because this expression is going to be 0. Now consider a question. What is the value of integration 0 to 3? Integration 0 to 3. Del of 2t integration. Simple question. Nothing is there. 0 to 3 sin 5 pi t. Whatever they have given sin 5 pi t dt. is equal to simply the limits are from 0 to 3. In between these limits, whether the given impulses exist or not, whether the given impulses exist or not. This del of t is t equal to 0. So limits are from 0 to 3. Definitely it is existed. So this value directly you can write sin 5 by 0. So this value equal to sin 0. This value is equal to 0. This 0 because this expression is going to be 0. For that purpose only this value is 0. Now what is the integration? What is the value? Integration from minus infinity to infinity. Integration from minus infinity to infinity. Sin of pi by 2 into t minus 2. Sin of pi by 2 into t minus 2 divided by t square plus 4 divided by t square plus 4 with into g of t dt into g of t dt, where g of t equal to what is the value of this? Consider the question. What is the value of minus infinity to infinity sin pi by 2 into t minus 2 divided by t square plus 4 into g of t dt, where g of t is given as limit a tending to 1, limit a tending to 1, limit a tending to 1, this is 1 minus a, limit a tending to 1, this is 1 minus a, corresponding amplitude is equal to 4, corresponding amplitude is equal to 4 divided by a, corresponding amplitude is equal to 4 divided by a. This is the signal they have given. This g of t is limit a tending to 1, the rectangular pulse like this with amplitude is equal to 4 by a. Then what is the value of this one? You have to calculate. What is the value of this one? You have to calculate. Just think how to what is given is that rectangular pulse as a tending to 1. What will happen as a tending to 1? This is the signal they have given. Limit a tending to 0. Sorry, a tending to 0. What will happen? Limit a tending to 0. Limit a tending to 0. This 1 minus a will become 1. Lower limit and the upper limit are coincident. Right? Clear that only. What is the first of all? What is this area of this pulse? Area of this given pulse. Area of this given pulse is equal to 4 by a into 1 minus of 1 minus a. This value is equal to 4 by a into 1 minus 1 plus a. This is equal to 4. Area of this impulse is equal to area of this rectangular pulse is equal to 4. As a tending to 0, this will become amplitude will become infinity, and width is reduces to 0, because 1 and 1 are coincide. Width is equal to 1 minus 1 is equal to 0. Width is equal to 0 and width is reduces and amplitude is going to infinity. That is nothing but area is constant at 4 only. So we can enter later this signal as the impulse signal of strength is equal to 4, excitation t equal to 1, So your g of t can be written as the 4 into del of t minus 1, amplitude strength is equal to 4, and the excitation t equal to 1. Now we have to calculate this signal, that is minus infinity to infinity. Limits are from minus infinity to infinity. So everywhere it is existed. So no problem, don't need to verify about the limits. Pi by 2 t minus 2 divided by t square plus 4 into 1 by 4 del of t minus 1 dt. This is the question they are asking indirectly. So this value can be represented as the simply 1 by 4 into sin of pi by 2 into t is equal to 1. You need to consider equal to 1 minus 2 upon 1 plus upon t equal to 1. This is nothing but 1 plus t square plus 4t. 1 plus 5. This is 1 plus 4. This is equal to 1 plus 4. This strength is equal to 4 here. 4 into. So this value can be represented as the 4 into sin minus pi by 2 upon 5. So this is equal to minus 4 by 5. This is equal to minus 0.8. Okay, the question looking to be very big question. Don't be confused. Whenever you see the rectangular pulse or triangular pulse with limits as a tending to 0, that is nothing but indirectly they have given the impulse signal only. We have to identify what is the strength of that impulse and where the impulse is existing. Consider one more question. Given f of t is equal to given f of t or f of x, whatever, limit a tending to 0, 1 by a triangular of t by a, 1 by a triangular of t by a they have given. And then what is the area of f of 4t and f of minus 5t? What is the area of f of 4t and f of minus 5t? They have given like this. Now here what is they given f of t is equal to limit a tending to 0 1 by a triangle of t by a. Then what is the area under the curve? F of 4t and f of minus 5t. F of 4t and f of minus 5t. Here the triangular parts. Here 3 by width. So a equal to width by 2. So width is equal to 2a. Width is equal to 2a. So this should exist from minus a to a. It exists from minus a to a, and corresponding altitude is equal to a. What is the area of this one? We have to concentrate first one. What is the area of this one? Area is equal to half into base into height. Half into base into height. 2 gets cancelled. This will get cancelled, and area is equal to 1. And a is tending to be 0. A is tending to 0 is nothing but width is going to be 0, and altitude is going to be infinity. But area is constant. So this can be written as the unit impulse signal del of t. Unit impulse signal del of t, whose strength is equal to 1 and exists at t equal to 0. So this f of 4t can be represented as f of 4t can be written as the del of 4t. F of 4t can be written as the del of 4t. Then what is the area of the signal? Area of the signal they are asking. So this can be represented as the 1 by 4 del of t. 1 by 4 del of t. Area of the signal minus infinity. F of 4t is equal to f of 4t dt is equal to 1 by 4 integration minus infinity del of t dt, whose value is equal to 1 only. So this value is equal to 1 by 4 square units. Now coming to f of minus 5t. Coming to f of minus 5t is equal to simply del of minus 5t. As we know, del of 8 is equal to 1 by mod a del of t. 1 by mod a del of t. So you can represent this is equal to f of minus 5t is equal to del of minus 5t. So this value is equal to 1 by mod of minus 5 del of t. So this is equal to 1 by 5 del of t. Now they are asking the area. That nothing but minus infinity f of minus 5t dt is equal to minus 5t dt is equal to 1 by 5 integration minus infinity del of t dt. So this value is equal to 1 by 5. Don't put minus 1 by 5. Okay, in option minus 1 by 5 also readily available. Because of this del of 8 equal to 1 by mod a del of t, we need to consider this corresponding positive value only. Those is equal to 1 by 5 only. 1 by 5 only. Like this, the signals operations, the representation of one signal is the other signal, the representation of signal is the step form or ramp form, in the ramp form, and some questions related to this simple signal. Those are very important. And the next questions we will see in the page 2. Furthermore questions for the practice we will see in the page 2. At this level, we have to know the concept and the questions clearly. Some questions based on this concept clearly. After completing of this phase 1 means after discussing all the topics of this JTCA in the month of November. In the month of November, we will have one more phase, that is in the only practice questions. At that time, we will see more and more questions on these topics So we have x of t multiply of del of t minus tau can be represented as the x of tau into del of t minus tau. X of tau into del of t minus tau. If you consider the integration from minus infinity to infinity, for this function, that is nothing but from a minus infinity to infinity with respect to d tau. Then the corresponding is equal to minus infinity d tau, and the signal can be represented like this: minus infinity x of tau into del of t minus tau d tau. Del of t minus tau d tau is equal to simply the integration is as these tau values are from minus infinity to infinity. Tau values are from minus infinity to infinity. Then we consider the sample values are exist from all the time axis from minus infinity to infinity. If you consider, suppose I am considering from minus 5 to 5, this del of t minus t plus 5 is nothing but x of minus 5 plus x of minus 5.5, x of minus 4.5 plus x of minus 4 plus like that. Each and every like that we have to consider the sample values, the values of this x of t and each and every values of this tau. A summation of all the samples, you will get the original signal only. So you can realize the x of t is equal to integration minus infinity x of tau into del of t minus tau d tau. Del of t minus tau d tau we can represent. We can write this x of t equal to minus infinity to infinity x of tau del of t minus tau. That is suppose for example I am considering this x of t, considering this signal as x of t, I am multiplying with the del of t minus tau. That nothing but tau is from minus infinity to infinity, as tau is from minus infinity to infinity. So this sample values, and if we consider the tau at a fixed value at some tau equal to 0, if you are consider the corresponding sample value equal to del of t at t equal to 0, you have to consider the corresponding multiplication will give you x of 0 into x of 0 into del of tau. Suppose if we consider the signal at tau is equal to 1, then x of 1 into del of t minus 1, as x of 1 into del of t minus 1. Similarly, x of minus 1 into del of t minus t plus 1. By adding all these values of doing integration, with integration and by adding all these values, what you will get is value equal to x of minus 1 plus x of 0 plus x of 1, like that. By adding all of these values, this corresponding minus 1, this corresponding 0 and this corresponding 1. By adding all these values from minus infinity to infinity, you will get the original signal only. So we can generalize the expression x of t can be represented as the minus infinity to infinity x of tau into del of t minus tau d tau. This is very important, this is very useful at the time of convolution. Okay, x of t into del of t minus tau d tau. Now, after seeing the operation of the signals, now the next one is the differentiation and integration of the signal. Differentiation and integration of the signal. Integration of the signal. As we know, the integration of this impulse is equal to your step signal. Integration of this impulse is equal to your step signal, and integration of the step signal is your ramp signal. Integration of step signal is your ramp signal. While drawing the signal in the impulse to become into the after doing the integration of the signal, which is represented in the form of the impulse, will become the step signal. The step signal will, by integration, this will become the ramp signal. While coming from step signal to the ramp signal to impulse signal to the step signal, the corresponding change in step is equal to the strength of the impulse at that instant, equal to strength of the impulse at that instant. Is equal to strength of the impulse at that instant. Corresponding the change in step at the instant is equal to the corresponding strength of the impulse at that instant. Similarly, while forming from step to the ramp, the corresponding change in slope is equal to the corresponding change in slope at the particular instant is equal to the corresponding change in step at that moment. Okay, while forming the step signal from the impulse, the corresponding change in step at the instant is equal to the corresponding strength of the impulse at the instant, and the corresponding change in slope at the instant is equal to the corresponding change in step at that instant. Suppose, for example, if we consider a signal x of t, is equal to like this, consider a signal x of t equal to like this. In the form of the impulse, at instant -2, this value is equal to 5, and the instant -5, this value is equal to some -6. That is the strength of the impulse equal to 6, and at 1 this value is equal to 1. They have given like that. They are asking to calculate the integration of this impulse. There is nothing but integration of x of t dt. This integration of this impulse will become the strength of integration of this impulse will become the step signal. So you are having the instances at t equal to -2, at t equal to -1, and t equal to 1. Okay, the corresponding step change at the instant -2 equal to the strength of the impulse at the instant t equal to -2. Here, what is the strength of the impulse, which is equal to 5? So the corresponding step change here should be 5. The corresponding step change equal to 5 is equal to present minus previous value. Starting the previous value, always you consider the 0. This value is equal to 0. So present step of this is equal to 5. So you have to consider up to this value. This is equal to step change equal to 5. Up to what value? Up to the next instant t equal to -1. Up to the next instant t equal to -1. At t equal to -1, what is the strength of the impulse? Which is equal to -6. So the change in step at the instant t equal to -1 should be -6. So the corresponding value can be represented as the -6 is equal to p minus the previous value, which is equal to 5. P minus the previous value is equal to 5. So the present value is equal to -6 plus 5, which is equal to -1. So the corresponding strength should be at -1. It suddenly drops to -1. Up to what value? Up to the next instant. What is the next instant? Next instant is equal to your 1. So what is the strength of the impulse at t equal to 1? The corresponding value is equal to 1. So the change in step is at t equal to 1. This 1 is equal to p minus of the previous value. What is the previous value? P minus of the previous value. Here the strength is equal to 1. So the change in step should be 1 only. So 1 is equal to p minus of -1. This is equal to 1 is equal to p plus 1. The corresponding present value at p is equal to 0. So at t equal to 1, the corresponding value is equal to 0. It is up to the next instant. There is nothing is mentioned about the next instant. So this is continuously 0 only. Now, what is the integration of this signal again? Already we know this is of the format of the step in nature. So the integration of the signal will become So the integration of this will become the ramp signal, and the corresponding slope changes are equal to the corresponding step changes. What are the instances where the step changes will occur? Instant equal to -2, -1 and 1, -2 and -1. So there should be some slope change at -2 which is equal to the step change value. Step change equal to how much here? Equal to 5. Slope change is equal to 5. So 5 is equal to present slope minus previous slope is equal to 0. So present slope should be 5 up to what value? Up to the next instant up to the next instant. At this instant, what is the change in step here? Here the change in step is equal to -6. So change in slope is equal to -6. So -6 is equal to present minus previous value. Previous slope is equal to how much? 5. Previous slope is equal to 5. So present slope should be equal to -6 minus of. So present slope should be equal to -6 plus 5 which is equal to -1 which is equal to -1. So present slope should be -1 here. Here what is the step change here is equal to -6. So -6 is equal to present slope minus previous slope. Previous slope is equal to 5. P minus 5. So corresponding value is equal to -6 plus 1 which is equal to -1. So from this -1 this value is going to be -1 up to what value? Up to the next instant. This may be like this. This may be like this, or this may be like this. That to be calculated, but that to be depends on the amplitude of the signal at t equal to 1. So what is the amplitude? First of all, what is the amplitude here? Here the amplitude is equal to, okay, here slope is equal to 5. I am considering this amplitude is equal to some value y. So corresponding slope 5 is equal to y minus 0 divided by minus 1 minus of minus 2. Right? Clear. Here the value amplitude here we are going to calculating the corresponding y2 minus y1, that is y minus 0 divided by minus 1 minus of minus 2. So this value 5 is equal to y divided by minus 1 plus 2. This value is equal to 5. So the corresponding value here is equal to 5. Here is equal to 5. This is the value. Now after this the change in slope is equal to how much? -1 we got. Change in slope is equal to -1 you got. Up to what instant? Up to the next instant 1. So the change in slope is equal to this one like this. Up to the next instant 1, the change in slope is equal to like this. Then what is the value? What is the amplitude at t equal to 1? You need to calculate. What is the value at t equal to 1? You need to calculate. Simply we know the slope here is equal to -1. Slope here is equal to -1. So -1 is equal to, I am considering some x here. At t equal to 1 instant, I am considering some x here that equal to x minus the previous value here is equal to 5. X minus 5, y2 minus y1 divided by x2 minus x1 here equal to 1 minus of minus 1, right? So from this you can write this value is equal to -2 equal to x minus 5. From this the corresponding x is equal to how much? X is equal to 3. The value amplitude at this value is equal to 3 up to this value equal to 3. Now what is the slope change at t equal to 1? Here the slope change which is equal to corresponding step change. Corresponding step change equal to how much? Here is equal to 0 minus of minus 1 which is equal to -1. So slope change should be -1. This -1 equal to p minus of previous one. What is the previous one here? What is the previous slope here? Is equal to the slope change equal step change equal to 1 here. One here. The 1 is equal to p minus of -1 equal to 1 is equal to p plus 1. So p is equal to 0. So present slope from here this onwards is equal to 0. This is way of the shape of this signal is equal to like this. Like this you need to calculate. Simple. Nothing is there. Okay. Simple mathematics only, simple coordinate geometry only. We are having the slope, the corresponding amplitude, and then we are having the slope, the corresponding amplitude. Depending on the amplitude, we can calculate the next slope. Okay. The intention, the points what we have to remember here is that only while forming from impulse signal to the step signal by doing the integration, the corresponding step change at the instant is equal to the impulse strength of the impulse at that instant. While forming the integration, while forming the ramp signal from the step signal. From this what you need to know, the corresponding slope change at the instant is equal to the corresponding step change at that particular instant in the previous one. That we have to remember. That is enough. While forming the integration and differentiation, we can calculate any question by using this one. Only 3 points we have to remember. Those 3 points only. Topics. Now consider the next topic of the signal is equal. Next topic is equal to even and odd nature, even and odd signals. even and odd. If you consider this f of t is a real valued signal, if you consider f of t as a real valued signal, the satisfy the condition f of t equal to f of minus t, the corresponding signal is called the even signal. If suppose f of t equal to minus f of minus t, the corresponding signal to be considered as the odd signal, odd in nature. How to verify? F of t is nothing but this values only. Values are nothing but with respect to y axis. With respect to y axis, suppose the signal is given like this, the minus 1 to 1. For minus 1 to 1, this is the signal f of t. For verifying the even or odd, we have to see, we have to move like this from this y axis. We have to move in this direction and in this direction. Whatever the direction you have to move in this direction, that same distance you have to move in the negative side also. In the negative side also, up to this whatever the amplitude here up to 0 to 0.5, the same amplitude to be exist in the 0 to minus 0.5 also, minus 0 to minus 0.5 also. Then such signal is called the even signal. Here I am moving from 0 to 1 in this side. I am moving from 0 to 1 in this side. Corresponding amplitude is equal to 1. So corresponding movement in this negative side 0 to minus 1, the corresponding amplitude is equal to 1 only. Then only you will call the signal is the even signal. If suppose the signal is given like this, if suppose the signal is given like this, here equal to minus 1 to 1, here equal to minus 1 to 1, here this is 0 by minus 1 to 1, and here this value is equal to 0.5, here this is minus 1, is here minus 1. So I am moving from up to 0 to 0.5, up to 0 to 0.5, this value is equal to 1, and here also this value is equal to 1. After 0.5 I am moving up to 0.5 to 1, this value is equal to 2 here, but this minus 0.5 to minus 9, here the value is equal to 1, here the value is equal to 1, this is not equal. So this is not a even signal, this is not a even signal. Or if you want to write this f of minus t separately, or if you want to write f of minus t separately, you can write and you can conclude the minus t, minus t equal to 1 and t equal to minus 1, multiply that minus 1 with the each and every instance of the time. So this can be represented as the simply 1 will become minus 1 and minus 1 will become 1. This shape is equal to like this only. If I represent this f of minus t, this 1 will become minus 1, this 0.5 will become minus 0.5. Minus 0.5, this is your shape. Is these two are equal? No, definitely not equal. So this signal is not an even signal. Like that also you can calculate. But if you want to see directly by this movement point of view, we have to move equal distance in the point of view. We have to observe the same distance to be moved in the negative side also. For these distance movement, we have to observe the amplitude. Those amplitudes should be same. Okay. Suppose they will give you the signal like this. They will give you the signal like this in examination, minus 2 and here is equal to 1. Here is equal to 1. They will give you. Okay. By seeing it is looking like a even signal only. If you are not concentrating about the limit, directly you may put a wrong answer. Readily available in the first option as a even signal, odd signal, either even or even like that. It is definitely looking like a even signal only. But the width point I will in the positive side width is equal to 1. In the negative side width is equal to 2. Width is equal to 2. So, okay, up to this one value, up to this moment, this value is equal to 1 and this value is equal to 1 also. We can say even signal. But after 1, what happened? 1 to 2, here the value is equal to 0. 1 to 2, here the value is equal to 0. But here 1 to 2, this value is equal to 1. So this signal is neither even, not an even signal. Okay, not an even signal. Very easy topic. So, okay. Very easy topic. Simply we have to not only considering the amplitude, we have to concentrating on the time limits also, time instances also. Now coming to this one, coming to this odd signal. This odd signal is nothing but simply the same concept. Whatever the distance movement, here in this positive side and the negative side should be opposite in nature. Suppose this value is equal to 1. Here this value should be minus 1. This value should be minus 1. Then the corresponding signal is said to be odd in nature. Corresponding signal can be said to be odd in nature, and every signal can be represented as every signal, either even signal or odd signal or whatever, either even or odd signal can be represented as the even signal and the odd summation of the even signal and the odd signal, or even component of the signal and the odd component of the signal. So this even component of the signal is given by f of t plus f of minus t divided by 2, f of t plus f of minus t upon 2, and the odd component of the signal is given by is equal to f of t minus f of minus t upon 2, f of minus t upon 2. Consider a signal which is neither even nor odd signal, that is from minus 2. That is from here equal to minus 1, here is equal to 2 and equal to 1. What is the nature of the signal? It is definitely neither even nor odd signal. What is the even? Every signal having the even component and the odd components, right? What is the even component of the signal? Even component of the signal is equal to f of t plus f of minus t divided by 2. What is f of minus t? F of minus t I am writing here. This will become minus 2 and this will become 1 only. So this is our f of minus t. F of minus t by adding these two signals. From up to minus 2 to minus 1, this value is equal to up to minus 2 to minus 1. What is this value? What is this f of t? And this is your f of minus t, right? Up to minus 2 to 0, minus 2 to minus 1. Here the value is equal to 1. Here the value is equal to 0. So you can write from minus 2 to minus 1. This value is equal to 1. This value is equal to 1. From minus 1 to 0. From minus 1 to 0. Here is equal to 1 and here is equal to 1. So the corresponding value is equal to 2 from minus 1 to 0. After this from 0 to 1, here is equal to 1, here is equal to 1. So to 0 to 1, amplitude is equal to 2. After 1, what will happen? Here this value 1 to this value is equal to 1, but here 1 to 2, the value is equal to 0. That value is equal to 0. This is up to 1. After this, the corresponding value is equal to 2. The corresponding value is equal to 2. This is your even component of this signal. Even component of this. What is the odd component of this signal? Odd component of the signal is nothing but simply simply subtraction of the signal f of t minus f of minus t divided by 2. F of t minus f of minus t divided by 2. So this is equal to 2 and we have to do 1 by 2 into this something. 1 by 2 into this something. So this will become 1 and the corresponding value is equal to 1 by 2. Okay, that we will see later. No problem. Okay, then what about this one? F of t minus f of minus t. Subtraction only. Subtraction of the signal only. Here the minus 2 to minus 1, this value is equal to 0. This value is equal to 0 and we are having minus 2 to minus 1 here value whose value is equal to minus 1 up to minus 1 up to minus 1. And after that here this minus 1 to 0 is equal to 1. This minus 1 to 0 this is also equal to 1. So by doing the subtraction this will be 0. By subtraction this will be 0. This will be 0. From here 1 to 0, 0 to 1 here is equal to 1. 0 to 1 here is equal to 1. 1 minus 1 is equal to 0. So up to this value this is equal to 0. Now after that here 1 to 2 this value is equal to 1. So here this 1 to this value is equal to 1. Here 1 to 2 equal to nothing is there. So this value is equal to 1 only. This value is equal to 1 only. Minus 1 and 1 with 1 by 2 you are having. So I am considering here minus 1 by 2 and minus 1 by 2. Here also you can take this 2 by 2 is equal to 2 by 2 and here is equal to 1 by 2. This is your odd component of the signal. FOC of f of t, odd component of the signal. This is your even component of the signal. Every signal can be represented as the summation of the odd component of the signal and the even component of the signal. Here how can you write? So the f of t can be realized from the summation of these two signals. Summation of these two signals. By adding these two signals, what will happen? You will see. From minus 2 to 1, what is the value here? Minus 2 to 1, what is the value here? 1 by 2. 1 by 2. From minus 2 to minus 1, what is the value of here? Minus 1 by 2. 1 by 2 minus 1 by 2 is equal to 0. 1 by 2 minus 1 by 2 is equal to 0. 0 is not a new thing. It's simple exclamation point of view only. So this is equal to 0. From minus 2 to minus 1, this value is equal to 0. Now what about this one? From minus 1 to 1, what is the value? 2 by 2 is equal to 1. 2 by 2 is equal to 1. Up to what value? Minus 1. From minus 1 to 1, this value is equal to simply your 1 only. Then after that, up to 1 to 2, this value is equal to how much? 1 by 2. And 1 to 2, this value is equal to 1 by 2. 1 by 2 plus 1 by 2 is equal to 1 only. So this value is equal to 1 up to 2 values. So minus 1 to 2. This is your signal f of t. This is your signal f of t. Here important conclusions are there. Listen, conclusions are there. This is your f of t signal. The corresponding signal is equal to f of t. Addition of this f of t and the FOC of t. Now listen. What is the area of this f of t? This conclusion is very important. What is the area of the signal f of t? Area of the signal f of t. Area of f of t is simply 1 into 2 minus of minus 1 which is equal to 3 is equal to 3 square units. 3 square units. What is the area of even component of this signal? What is the area of even component of this signal? This is summation of area up to this level. This 1 by 2 into 1 by 2 area of even component of this signal. This is equal to simply 1 by 2 into 1 plus 1 into 2 plus 1 into 2, right? Plus 1 into 2 plus 1 by 2 into 1 plus 1 by 2 into 1 by 2 into 1. What is summation of this? This is equal to 1 by 2 plus 2 plus 1 by 2. This value equal to 3 square units. What is the area of odd component of this signal? What is the area of odd component of this signal? What is the area of this one? Here this value equal to 1 into minus 1 by 2. 1 into minus 1 by 2. 1 into minus 1 by 2 plus 1 into 1 by 2. So this value equal to minus 1 by 2 plus 1 by 2. So this is equal to 0. This is equal to 0. So any signal f of t can be represented as the summation of the even component of the signal and the odd component of the signal. That is even component of the signal and the odd component of the signal, that is FEC of t plus FOC of t. This signal, this one only, f of t equal to this one, and area of this f of t is equal to simply area of the even component of the signal, and area of the odd component of the signal is always 0. Put a note and write down. Area of this odd component of this signal is equal to always 0, and area of the signal f of t is equal to area of the even component of that signal. Area of the even component of the signal. And the corresponding even component equal to this one, and corresponding odd component equal to this one. What are the even component of the? What are the even components and odd components of the signal u of t? Of the signal u of t, what are the even components and odd components of the signal u of t? And what are the even components and odd components of the signal sin t into u of t? Sin t into u of t, write down. Simply f of t plus f of minus t upon 2. Now simply f of minus t upon 2 and the given signal. Write down. F of t equal to the given like this. What is the nature of the signal? First we will see later, no problem. First of all, write down. What is the even odd component of the signal? FEC of t equal to simply u of t plus u of minus t divided by 2. U of t plus u of minus t divided by 2. So this can be represented as the 1 by 2 into u of t plus u of minus t. What is the value of u of t plus u of minus t? U of t plus u of minus t. U of t equal to this one and u of minus t equal to this one. By adding these two, what you will get? The DC signal of amplitude is equal to 1 by 2. DC signal of amplitude is equal to 1 by 2. Now what about the odd component of the signal? Odd component of the signal is equal to simply 1 by 2 into u of t minus u of minus t. What is this value? This is equal to 1 by 2 into signum of t only. U of t minus u of minus t. U of t is nothing but this one minus u of minus t is equal to signum function only. So this can be represented as 1 by 2 into signum of t. Like that they may ask you, what is the even odd component of this signal? For this signal, the even component of the signal is equal to simply sin t into u of t plus sin minus t into u of minus t. Sin minus t into u of minus t divided by 2. So this can be represented as the sin t by 2 into u of t minus u of minus t. So this is equal to sin 1 by 2 sin t. So this is equal to 1 by 2 sin t into signum of t. 1 by 2 sin t into signum of t. Nothing is there. For odd component, what will happen? Is equal to sin t into u of t. This minus will become plus, and odd component is equal to simply sin t by 2. Simply sin t by 2 is equal to even component of the signal is equal to 1 by 2 sin t into signum of t. Odd component will become FOC of t equal to simply 1 by 2 sin t, since this u of t plus u of minus t you will get. The corresponding signal is equal to 1 by 2 sin t. Even this should be odd nature. It should be odd in nature. Exact opposite is odd in nature. This is sin is odd in nature, so this is odd. Now what about this one? FEC of t 1 by 2 into sin t into signum of t. Sin t is odd and this one is odd. Odd into odd is your even. Odd into odd is your even. You have to remember the odd into odd is equal to even, and even into even is equal to even into even is equal to even, and even into odd is equal to odd in nature. Even into odd is equal to odd in nature. In convolution it will be clear. In convolution it will be clear, very clear. It will be clear, no problem. Odd into odd is even into even is even, and odd into odd is your odd. Here also it will be clear. This is odd signal. Sin t is definitely odd signal. What about signum of t? Signum of t definitely odd signal only. Signum of t, what is the signum of t? Signum of t, odd signal or even signal? This is odd, this is one, this one. Wherever you go, 0 to infinity, this value is equal to 1. And in left side, 0 to minus infinity, this value is equal to minus 1. Definitely it is a odd signal. Signum of t is a odd signal. So the corresponding odd component is equal to like this. Coming to this one, the given f of t equal to like this. Coming to this one, the given f of t equal like this. Comment whether the given signal is a even or odd. Even or